We have the second talk by Professor Hema. She will present the text-to-speech system. And Professor Hema is from Department of Computer Science and Engineering of IIT Madras. She has expertise in speech processing and machine learning. Welcome, Professor.
I think there's no introduction that is required, since you already know speech recognition, where you speak and the text is produced. This is just the reverse process, text-to-speech synthesis, where you type in the text and you produce the speech output. So here is, since this is a workshop, I thought I should give a picture of what speech generation recognition is all about. This figure is being reproduced. So basically the idea is, how do you produce speech? First of all, you formulate the message in the brain, and then we do not know how message is actually represented. Then you decide to speak it in a language, and then there are what are called neuromuscular controls, and then which excite what's called your vocal tract, and you produce the acoustic waveform. And then once you've spoken, what happens is, the difference between text-to-speech synthesis and speech recognition is, when you produce speech, the ear is the listener, and the ear does not tolerate any errors at all. In speech recognition, you can have 1 or 2 errors. In speech synthesis, the ear wants 0% word error rate. So this is all that I want to show with this picture. And this here is a picture that says how speech is actually produced. And speech synthesis, we essentially try to use. What happens is, it's very interesting that the way nature has made us, as you exhale during your respiratory process, that is used for producing speech. Your vocal folds vibrate, and there's a vocal tract which is like a flute. It excites the vocal tract and sound is produced. So if you look at our script, for example, ka, cha, ta, ta, pa, the tongue is touching at the back, then it moves forward, and so on. Our script is one of the most beautiful scripts. Ka at the back, your tongue is touching, cha, ta, pa, from back to front. Okay? So you place your tongue in one place, and then you excite the vocal tract, and the sound gets produced. So what we try to do in speech synthesis, we try to reproduce this effort. So this is the ear, picture of the ear. You listen from here, and what this does what's called an impedance matching, so that people say very loud sounds and soft sounds, your eardrum doesn't get affected, and there are these set of bones which further do the impedance control. And this is the most important part. This is called the cochlea, through which you actually listen to sounds, which actually responds to frequencies and distinguishes between the various sounds. So far about speech perception and speech production. So what is our task here? Given an input text, we want to synthesize speech output. Now let me give you a little bit of, and what is the application of all of this? It has very many applications: email readers, information access. In fact, we have built at IIT Madras a number of tools for the visually challenged. In fact, we used to run a workshop for visually challenged where they could use the regular keyboard and produce, type in the text and listen to the text and so on. We use what's called non-visual desktop access, and we put 13 Indian languages into it. So you can type in Bodo, you can type in Hindi, you can type in Tamil, Telugu, whatever it may be. And we taught people email, internet, and docs, and spreadsheet. And it was an amazing experience for us. We also learned a lot. We trained about 180 visually challenged people to use computers. And one of our visually challenged people, I'm very proud to say today, is faculty in Presidency College. And he always reversed the experience that he got in our lab, that once he learned to type, automatically there's no difference between him and any other normal person. And of course, tools for augmentative and alternative communication. We work with Chetana, an organization called Awareness, where we build devices for people with cerebral palsy to produce a voice for them. And we continue to work with what is called Enability Foundation, picture to sound, and so on and so forth, where Anil Prabhakar, Namita, Jacob are the founders who have set up a company in the research part. So let me give you a little bit of history, okay? I'll just put all these things out. Here is a video clip of what was built in the 1930s.
The machine uses only two sounds produced electrically. One of these represents the breath. The other, the vibration of the vocal cords. There are no phonograph records or anything of that sort. Only electrical circuits, such as are used in telephone practice. Let's see how you put expression into a sentence. Say, she saw me, with no expression. She saw me. Now say it in answer to these questions. Who saw you? She saw me. Whom did she see? She saw me. Did she see you or hear you? She saw me.
So, what is very interesting about this example, remember this was built in the 1930s. There are only two sounds, okay? If there are 50 sounds in the language, you have 50 to the power unit, 5 units, that's what we try to do. There's something called parametric modeling, and as soon as parametric modeling came about, we'll show about this also, it immediately reduced the footprint. And you will put it on an Android phone. You put this on an Android phone, and it will read out for you whatever text you have, no internet required, nothing required. And today, for example, we have the neural network-based systems, the conventional one, and also the end-to-end system that Umesh already talked about in the context of speech recognition. Since speech synthesis is simply the reverse, we use the same idea in the reverse. Okay, so what we did was we first built this unit selection synthesis. Indian languages are what we call syllable typed. What we mean by that, for example, ma, gar, ja, ra, ha, hu. For example, my is one syllable, gar is a syllable, ja is one syllable, ra is a syllable, ha is a syllable, hu is a syllable. So you simply store these syllables to some extent in different contexts and reproduce it. Here is an example.
नमस्कार, आज के कार्यक्रम में आपका स्वागत है.
So this is how it produced, and it's almost quite natural if you can see it. These are called syllables, and let me play it again.
नमस्कार, आज के कार्यक्रम में आपका स्वागत है.
Okay, this namaskar, for example, was not written. It's quite natural sounding though. It's quite legible. And then what happens is you can not only store one syllable, you can store many syllables. You can take a polysyllable. We've done a lot of experiments on this. And what we have found is initially, for example, the longer the unit you use is better. As you go along, you can do shorter units and so on. Then we come to the hidden Markov model-based speech synthesis. Umesh also talked about it for speech recognition. Remember I said the vocal folds are vibrating and then it's exciting the vocal tract. So he said, can we repeat the same thing in terms of a model? And that's precisely what we do over here. So we store the vocal fold vibrations and the vocal tract shape and reproduce the speech output. So basically you have a vocal tract and then you have this, this puff of air which you are exciting the vocal fold with, just like how you're doing during respiration. And then we do a lot of information about phonetic, linguistic, prosodic, and so on. She saw me, for example, how do I put the me back, and so on. And we build what I call, as I said, we use a pentaphone context. For example, it is a lovely day. I take the phone in the context of two other phones on the left and two other phones on the right. Becomes very large, as I said, 50 to the power 5. But what happens, what is interesting is some combinations do not occur. And then what is nice about the parametric model is, even if the context is not seen, it will produce a speech. It will produce something very similar. Okay? Suppose I say la, and then I don't have la, then it will put la at least over there and reproduce a sound. That's been the good thing about these parametric models, even though it may not be accurate. So let me play you some examples. This was the
इसरो ने कहा कि मिशन रेडीनेस रिव्यू कमेटी और लॉन्च अथॉराइजेशन बोर्ड ने इस उल्टी गिनती को मंजूरी दे दी है.
ലോകത്തിന്റെ വിഭിന്ന ഭാഗങ്ങളിൽ ഉണ്ടാകുന്ന പൈശാചിക സംഭവങ്ങളെ മുൻനിർത്തി യുവാക്കളെ തീവ്രവാദ പ്രവർത്തനങ്ങളിലേക്ക് നയിക്കുന്നതിനുള്ള നീക്കങ്ങൾക്കെതിരെ ജാഗ്രത പാലിക്കണമെന്ന ആഹ്വാനം.
So this was, although it has a little bit of a muffling in the voice, let me play that.
தியாகம் ஒழுக்கம் முதலிய குணங்களில் போலவே வீரபௌருஷத்திலும் சிறந்தவர்.
Okay, so we can do about 13 Indian languages. The good part is very, very small footprint, and synthesis is very fast, and especially today with very smart Android phones, you can do a lot of this. It's a little bit muffling, as we saw. Then we move on to neural network-based synthesis, where the first neural network-based system, the conventional thing was you would give all this linguistic rules, pentaphone context, where is it occurring, is it in the middle of the sentence, in the beginning of the sentence, end of the sentence, all kinds of information had to be provided. Is it the sound at the back, is it the sound in the middle, is it the sound in the front, and all that. And this was using what is called Merlin, and we produced this.
आंतरिक विस्थापित लोग सरकारी सामाजिक सुरक्षा पाने में असमर्थ होते हैं.
So immediately you see the little bit of better quality, but this takes a lot of time to train. Now the end-to-end speech synthesis, you don't have to develop separate models. No parsing the text. Earlier, for example, when we talked about syllable-based synthesis or basic unit synthesis, we had to take a given text, convert it to the basic sounds, look at the database of the basic sounds and produces them. So you don't have to do any of these things today. You give the text in and then the speech output. And there's a nice paper on a survey on neural speech synthesis. There are 4 different models, the tachotron, the fast speech. Umesh already told you about the transformer model. This is what fast speech is based on. And Dr. Tachotron, who is essentially an autoregressive model. Basically the idea is you give the character sequence or the sound sequence and the speech waveform gets produced. So one way of looking at it, there is a text. Earlier we used to use what is called, the text used to be parsed into the text that we wanted. Then we had to model how much time that particular sound has to be spoken about. I want the same thing to be done. I want the same thing to be done. The A is longer there. All this information has to be produced. You have to produce the various sounds in the particular context and be produced. And the good part about these end-to-end systems is they simply do not require anything. You give the text and the corresponding waveform and it produces a text output. And here is an example here. What we did was, the important point is, as expected, as Umesh also said, it requires in-speech recognition, large amount of data to produce good quality speech. So same thing happens in speech synthesis also. For example, you need 50 to 60 hours of data to produce good quality speech synthesis. What we have done at IIT Madras is, for example, we are collecting about, we just collect about 10 hours per language, and we use some clever way of understanding Indian languages. We have adapted these end-to-end systems to work for Indian languages in a particular way. What is it that we use? Indian languages are known to be syllable timed. What is the meaning of that? When you speak a sentence, almost every syllable will be about the same duration. We use that property, and because of it, what requires 50 hours, we have been able to reduce it to 10 hours. And I'm very proud to say today we have collected for 16 Indian languages and many flavors of Indian English. For example, you have a Hindi accent in English, you have a Tamil accent in English, Marathi accent in English, Telugu accent in English, and so on. And everything is perfectly transcribed. In fact, almost all the TDS systems that have been produced in India use the database that we have created. It's freely available on the web for download. Anybody can download and use. We say copy right, copy left, whatever, copy top, copy bottom. Use it, just acknowledge that Umesh and I have produced this data. That's all that we ask for. Let me play you an example. Okay? This is what we've been able to achieve.
नमस्ते, हम क्लाउड कंप्यूटिंग पर हमारी चर्चा जारी रखेंगे। आज हम इस क्लाउड कंप्यूटिंग के एक एप्लीकेशन पर एक पहलू देखेंगे, या आप कहेंगे कि अन्य तकनीक के साथ समामेलन है।
Some Samamel made a little bit of a mistake over there. Remember that this had both English and Hindi text. This is typically, as he said, conversational speech, where you have bilingual data. We speak, we want to produce this. I noticed that the sentences are not even complete. Where have we picked this up from? We picked it up from lectures. People are doing these lectures. So now what I'm going to do is, I don't know how much time I've already spent. Let me play Urdu, we're not playing Urdu a very long time.
ये फिल्म हॉलीवुड में भी मकबूल है और इसीलिए बीबीसी की मेरिल सेबास्टियन ने ये जानने की कोशिश की है कि इस फिल्म में ऐसा किया है जिसने दुनिया भर के नाजरीन को मशहूर कर रखा है।
So we have Urdu, we have Punjabi, we have Bodo and many other languages. We're correcting Konkani, all the other, Maithili, Santali and so on. So the good part is end-to-end speech synthesis sounds very good. It's computationally intensive, easy to train and so on. So what we did was, remember sometime back I had said there's a parametric model where I can, so now what we do is we do a marriage between them. And now we have a small footprint speech synthesizer. I'm not going to go into details of it, let me just play this for you. This is what the end-to-end system gives.
सुकरात ने उस लड़के से कहा कि तुम कल मुझे नदी के किनारे मिलो।
And this is the proposed system.
सुकरात ने उस लड़के से कहा कि तुम कल मुझे नदी के किनारे मिलो।
And the size of the footprint is so small that you can put it on an Android phone. It kind of combines the benefits of the parametric model and the end-to-end systems to produce a speech. So now it can run standalone as an APK. We're still building the APK. If somebody can help us with it, that will be really very good to put it on an Android phone. And of course, I'm thankfully fun for creating the APIs for our TPS systems. And now finally, this is, as Umesh talked about, here's the consortium effort on. So what are we going to do with all these details? What we did was we started doing technical lectures, and we said we'll take the source videos which are in English, convert the speech to text, Umesh's software, and then we do a little bit of manual editing, and then we put it through machine translation. This was done by IIT Hyderabad and IIT Bombay. Then you produce it in a particular language, and then you do a little bit of manual editing, put us through speech synthesis, sync the audio back with the original video. Okay? So you have a lecture which was there in English now in Indian languages. Let me show you what we have done. I'm not going to go into this details. The fundamental problem is that Indian language sentences after translation are generally longer. Okay? So what we do is we have to do some interpolation of the video because we don't, it's well known that perception of the ear is very sensitive. Visual, for example, I can do a little bit of jerky video, you're okay with it. For example, how many times all of us stare, on the newspaper, one image is there, whose picture it is. But you play blurred audio, nobody will listen. So what we do is we kept the audio good, but we interpolated the video. This gives you some techniques of how to generate punctuation. And the problem is English in terms of structure is a very different language. To produce similar punctuation in Indian language is totally different ballgame altogether. We did a lot of stuff, and not only this, somehow put the speaker's rhythm back. I'll play you some examples where we, let me show you a video with the face. This is the original video here. Oh, sorry. Let me do the one with the face here.
As I said, the beginning, this course is about learning setups, learning different learning setups, looking for the best algorithms. When I say best, if I'm saying something is best, I need to show it, like this is the best. So how one is going to show something is best? That you have to say that you can't do better than this. Okay? So our focus of this course will be like coming up with the algorithm and then showing their best through giving a detailed analysis. Because of that, as we grow on this, as we go into this course, we will get into a lot of analysis. So you have to be like with focus. Sometimes the proofs and all can get dry. So if you lose track, then you will be totally lost for the rest of the class. So interrupt me at any point if you are not following anything. So it's not necessary that we have to cover all the proofs. But till whatever steps we are going to cover in the proof, it's important that we are all in sync with that.
I've just taken so the topic is completed.
Okay, so what is our supervised learning method? What we have? So basically supervised thing is, you have, let's take the simplest case of classification. For the simplest case, that is a binary classification. You have given an instance, you have to say whether it has a label 0 or 1. So let's try to set up this simple thing in a bit more formal way. So this is just a small topic that he has covered. Let me show the same thing in UV. The sound of writing on the board for that voice acuity detection removes it off, so you don't hear the sound of him writing on the board.
तो जैसा कि मैंने शुरुआत में कहा था कि यह पाठ्यक्रम अलग-अलग लर्निंग सेटअप को सीखने के बारे में है। सबसे अच्छा एल्गोरिदम की तलाश में जब मैं सबसे अच्छा कहता हूँ, अगर मैं कुछ कह रहा हूँ तो मुझे यह दिखाने की जरूरत है कि यह सबसे अच्छा है। तो कोई यह कैसे दिखाने वाला है कि कुछ सबसे अच्छा है? जो आपका कहना है कि आप इससे बेहतर नहीं कर सकते। इसलिए इस पाठ्यक्रम पर हमारा ध्यान केंद्रित होगा एक एल्गोरिथ्म निर्धारित करने और फिर एक विस्तृत विश्लेषण देने के माध्यम से अपना सर्वश्रेष्ठ दिखाने के लिए। इस वजह से जैसे जैसे हम इस पर पढ़ते हैं, हम इस पाठ्यक्रम में आते जाते हम बहुत विश्लेषण करेंगे। इसलिए आपको थोड़ा सा ध्यान केंद्रित करना होगा। कभी-कभी सबूत आदि सूखे हो सकते हैं। यदि आप ट्रैक खो देते हैं तो हम शेष कक्षा के लिए पूरी तरह से खो जाएंगे। इसलिए मुझे किसी भी पॉइंट पर बाधित करें। अगर कुछ भी अनुसरण नहीं कर रहे हैं तो यह आवश्यक नहीं है कि आपको सभी प्रमाणों को कवर करना होगा, लेकिन जब तक हम समूह में कदम रखने जा रहे हैं तब तक यह महत्वपूर्ण है कि हम इसके साथ तालमेल बिठाएं।
So this was, we've done this conversion for Hindi and Tamil, but some of it was very flat. So I want to show you something else where we've tried to put in those.
हम देखेंगे कि प्राइवेसी ब्रीच होने पर क्या होता है। सबसे पहले ये सभी सवाल हैं। सपोज करो मैं एक क्लाउड सर्विस प्रोवाइडर का ग्राहक हूँ। मुझे कैसे पता चलेगा कि एक ब्रीच हुआ है? यदि एक ब्रीच हुआ है तो दूसरे शब्दों में मैं कैसे सुनिश्चित करूं कि जब भी कोई ब्रीच होगा तो क्लाउड सर्विस प्रोवाइडर हमें सूचित करेगा कि ब्रीच वास्तव में हुआ है। अब ब्रीच नोटिफिकेशन प्रोसेस और इस प्रोसेस से जुड़ी हुई कॉस्ट को मैनेज करने के लिए कौन जिम्मेदार है? तो वास्तव में एक सबसे महत्वपूर्ण चीज है जो तब होती है जब सिक्योरिटी पॉइंट ऑफ व्यू से कॉन्ट्रैक्ट साइन किए जाते हैं। इन कॉन्ट्रैक्ट्स में जो चीजें हो सकती हैं वह मुख्य रूप से प्राइवेसी ब्रीचेस के लिए होंगी।
So this was the original one without the proper procedure, and let me show you what we have tried to do. Put in the.
अब हम देखेंगे कि प्राइवेसी ब्रीच होने पर क्या होता है। सबसे पहले ये सभी सवाल हैं। सपोज करो मैं एक क्लाउड सर्विस प्रोवाइडर का ग्राहक हूँ। मुझे कैसे पता चलेगा कि एक ब्रीच हुआ है? यदि एक ब्रीच हुआ है तो दूसरे शब्दों में मैं कैसे सुनिश्चित करूं कि जब भी कोई ब्रीच होगा तो क्लाउड सर्विस प्रोवाइडर हमें सूचित करेगा कि ब्रीच वास्तव में हुआ है। अब ब्रीच नोटिफिकेशन प्रोसेस और इस प्रोसेस से जुड़ी हुई कॉस्ट को मैनेज करने के लिए कौन जिम्मेदार है? तो वास्तव में एक सबसे महत्वपूर्ण चीज है जो तब होती है जब सिक्योरिटी पॉइंट ऑफ व्यू से कॉन्ट्रैक्ट साइन किए जाते हैं। इन कॉन्ट्रैक्ट्स में जो चीजें हो सकती हैं वह मुख्य रूप से प्राइवेसी ब्रीचेस के लिए होंगी। और
So this is what we have been able to achieve. Somebody asked about voice conversion. Last year we had done voice conversion, but we've kind of stopped it right now because of all these legal issues about fake voice and so on and so forth. So this is where we are. We are able to, we've actually done there's a set of Python lectures which don't have a face, and we've done it in Hindi, Telugu and Tamil, which are available, entire set of 45 lectures. We hope to do a workshop to see how useful it is. And evaluation of these systems is very difficult. What we do is we use, generally it's what's called a mean opinion score. How would you feel? Can you listen sustained for about 15 minutes, 20 minutes? That's what we look at. There's something called a degradation mean opinion score. When you're listening to someone's voice, you don't like the voice very much, so that can also affect. So how have you rated the original voice and how have you rated the synthesized voice? We do pair comparison tests and so on. So a lot of work to be done, multilingual aspects. We do bilingual code mixing, and prosody expressive speech synthesis is much harder. That's what we are realizing. Producing emotional speech synthesis, voice conversion, and finally, actually, what we did in our dubbing lectures, we didn't put back the R's and Ms, which are actually necessary when a person is giving a lecture. How can we put that back? There are still questions. What are the equivalent of, I wanted to say this. What will it be in an Indian language? How do we put those things back to make it sound a lot more natural? So let me stop here. Okay? Thank you.